Welcome back. Let's do question 7. The diagram below shows two vertical poles, AD, this is AD, and BC, this is BC. Right? Point E lies on the same horizontal plane as bases D and C of the poles AD and BC. So it means point E here is on the same horizontal plane with D and C. They are forming a triangle DEC on the horizontal plane, right? So this is like 3D. We're given the angle AEB, which is 2 alpha, BEC, which is alpha, and then ABE, which is 90 minus 3 alpha, and then BC, the whole BC is y meters. Determine BE in terms of alpha and y. We're looking for BE, this side, right? And then if we check, we have this triangle BEC. We want to find BE in terms of y and alpha. We have the angle here alpha, we have y there. What type of triangle is triangle BEC? This is a right angle triangle, right? With right angle triangle, we can use the Pythagoras theorem, we can use trigonometric ratios. So here we can use the trigonometric ratios. As angle alpha is our reference angle, y is the opposite side, and BE is the hypotenuse. So which trig ratio involves the opposite side and the hypotenuse? That would be sine of an angle. So we can say sine alpha is equal to the opposite side, which is y, over the hypotenuse, which is BE. And then this is like sine alpha over 1. Here we can just cross multiply and say BE sine alpha is equal to y. Some of these steps you can skip if you know how to do it. I'm just doing all the steps because I'm explaining here. Then divide by sine alpha on both sides. BE is equal to y over sine alpha. This is the answer for 7.1. So this is y over sine alpha. Right. Let's do question 7.2. We are required to show that AB is equal to 2y. AB, this is AB. Alright, this is AB. Alright, AB is in triangle, which triangle? And then we just found BE. We just found BE. So it means somehow we may be required to use this BE. We may be required to use this BE. So if we check AB, BE, and AE, they form a triangle. These three sides form a triangle, this triangle, right? And then we want the side AB. Let's start by checking the sine rule because it's easier. Most of the time it's easier than the cosine rule. So AB, this is AB that we're looking for. We have the side angle pair. Okay, we have the side angle pair there. And then we just found EB. You can have also the side angle pair like that. But now there's A, angle A missing there, angle BAE. BAE is missing. Can we find this angle? Yes, we can, because we have angle AEB and angle EBA. So using these two angles, we can find what angle A is. And then once we find angle A, then we can use the sine rule. Remember, for us to be able to use the sine rule, we just need one pair of angle side pair, and one other angle or one other side. Remember that for the sine rule, when you're given one angle side pair and then any other angle or any other side, you can use the sine rule. Cosine rule, you need two sides and an included angle. The angle must be between the two sides. It should be side, angle, side. Like here, let's say if we say we're given this side, we're given this side, and then we're given this angle. This is side, angle, side. This angle, the angle must be included. And also you can use the cosine rule if you're given the three sides. Okay? And then area rule also, we need side, angle, side. Just know what you need for you to be able to use these rules. The sine rule, cosine rule, and the area rule. Right, let's find angle BAE is equal to 180 degrees minus, we have this angle here 90 degrees minus 3 alpha, so we subtract that. Okay, and then minus 2 alpha, right? And then there is in here sum of angles in triangle. right? And then this becomes 180 degrees minus 90 degrees plus 3 alpha, then minus 2 alpha, right? 180 minus 90, that is 90 degrees, and then 3 alpha minus 2 alpha, that is alpha. So it means this angle here is 90 degrees plus alpha. Okay, now we can use the sine rule for this. We want AB, so it's going to be AB over sine 2 alpha is equal to BE over sine 90 plus alpha, right? Okay, and then we're still looking for AB, so AB is equal to sine 2 alpha. Sine 2 alpha is like 2 sine alpha cos alpha, isn't it? And then BE, we have y over sine alpha, then divided by sine 90 plus alpha, this is cos alpha, right? Okay, right, then we can multiply by 2 sine alpha cos alpha on both sides of the equation. AB is equal to y over sine alpha, then times 2 sine alpha cos alpha, all this over cos alpha. Then sine alpha divided by sine alpha is 1, so we remain with AB is equal to 2y cos alpha divided by cos alpha. Then cos alpha divided by cos alpha is 1, so we remain with 2y. So we've managed to show that AB is equal to 2y. It is further given that AF is equal to 7 over 4 BC. BC, we say that BC is equal to y. So AF, this is like 7 over 4y. Determine angle BAF. We want to find this angle here, right? So what we have this side, which is the hypotenuse for this triangle. Okay, we have this side, which is the hypotenuse of this triangle, and then we have the adjacent side. If this is our reference angle, okay, let's call it theta. This is our reference angle. So our angle BAF is our reference angle. This is the adjacent side. This is the hypotenuse. So which trig ratio are we going to use here? It will be the cosine of the angle. So we can say cos BAF is equal to the adjacent side, which is 7 over 4y divided by 2y. So it becomes 7 over 4y times 1 over 2y. Then y divided by y is 1. We remain with 7 over 8. So now this is cos BAF, right? And then now BAF is the angle. We're going to arc cos 7 over 8. And then what do we get? Angle BAF is equal to 28,955, goes on like that, which is roughly 29 degrees, because they said give your answer to the nearest degree, so that is 29 degrees.